Hey everybody, this is Brian. Welcome to the 11th Flutter tutorial. I'm hoping we can wrap up classes today. Not going to really cover enumerated types because it's kind of a little different, but what we're going to cover today is mixins. Let me back up. When I say enumerated type is kind of different, it's more or less used as a variable. We will cover these in future tutorials, but right now we're going to really cover mixins. So what is a mixin and why do we need it? So it says mixins are a way of reusing a class's code in multiple class hierarchies. To use a mixin, use the with keyword followed by one or more mixin names, and then some examples. And I kind of wanted a better description. So a better description is in object-oriented programming languages, a mixin is a class that contains methods for use by other classes without having to be the parent of those other classes. So you kind of take inheritance as a fundamental hierarchy and you break that. And it's not really interfaces with abstraction. It's kind of like just saying, hey, I don't really want to use the whole class. I just want this little part of it, meaning I don't want to really inherit it and I don't want to have to be tied to it. It's kind of weird. So let's just make our new project here. And this will calculate the sun, moon, and stars. There we go. Let's go out here. Did my music stop? I think my music stopped. Yep, I'm still listening, Pandora. Thank you for doing that, Pandora. Alright, so back to what we're working on here. We are going to make a car. We're going to make a concrete class. And we're going to say int doors. Make a getter for this. We're going to make a black car because why not? Black's awesome. And we want to play music in our car. And we're just going to say boom, I don't know, just music, whatever. So we've got 4 doors, it's a black car, and we're just going to play some music. All right, so pretty simple class, not a whole lot to it. Now we're going to make a truck. Going to make this concrete as well. And we're going to say bool has 4x4 because you need that with a truck, especially here in Michigan. Give this 2-door. We're going to stay string color. I want a... what color truck do I want? Let's make it a red truck. Giant, big, red monster truck. And we're going to say void. I'll honk the horn. Why not? So we've got a car class and we've got a truck class. Now let's say we want to make a hybrid of those. We want a Jeep. Actually, let's call it an SUV. I owned a Jeep for years and years and I loved it. So in this we're going to import the car class and we're going to import the truck class. We're going to make another concrete class called SUV, and we're going to extend the truck. But this time we're going to say with the car. What the heck? What's that mean? Alright, so let's see what we got going on here. Color is inherited as a getter and also as a method. Ooh, I screwed something up here. See, there's color. Oh, yeah, that's why. There we go. Fix that problem. Alright, so our SUV here extends truck with car. What does that mean? Well, that's interesting. Let's find out. In here, we're going to import the SUV. We're going to say SUV Jeep equal new SUV. And let's just examine this object and see what we got going on here. You can see how we have colors, doors, 4x4, it has a bed, it honks the horn, plays the music. It does all the things that we want it to do. So we can actually say, you know, honk the horn, Jeep dot play the music, and let's say we want to print the number of doors, and we want to print the color. Let's see what happens here. So we honk the horn, we play the music, we have 4 doors and it's black. Well, where did it get 4 and black from? That's interesting. Well, if we look at this, you can see we're extending the truck with the car. So if we look at the car has 4 doors and it's black, so that's where it's getting that from. If we flip those around, you guessed it, we're extending a car with the truck. It will now have different properties. It'll now have 2 doors in red. So that's really how a mixin works. You can kind of piecemeal classes together and use the parts that you want without really having to mess around too much with interfaces and inheritance and abstraction. It's kind of I'm not a big fan of it, to be brutally honest with you, because as you can see, if you do things in a specific way, you can change the outcome of what you expect. Like, I'm going to flip this back to truck and flip this back to car, and then bang. So, you know, you really get some unexpected results sometime. Now, some would argue, well, you know what results to expect because of, you know, the way you're ordering things and all that. Let's just, for giggles here, I'm actually just going to try this. Let's say, I have no idea what to call this. Industrial. We're going to make an industrial vehicle. And we literally are just going to copy this car class here. And we're going to say this is, what haven't we used? Blue. And we're going to give this like 900 doors. And of course, there's no way to play music in this thing. Let's go back to our SUV. Whoops. It's funny, I always get this viewer feedback where everybody's like, we actually like watching you make mistakes. We learn from your mistakes. I'm like, you guys are so mean to me. So now we're extending the truck with the car and the industrial equipment. Let's see what this does here. We'll run this. Suddenly it's got 900 doors and it's blue. So the problem here is that it's picking up the last one. Now, I'm not sure if that's actually a standard or if it depends on what sort of just-in-time compilation you go through. So if you get a different vendor's just-in-time compiler, it may take the first one and not the last one. So now you've got to actually account for those and make, you know, functions that do that. You should actually say string color equal, I have no idea what to make my Jeep here. Lime green. It's like the ugliest color on the planet. And then you should actually say int doors equal, and we want 3 doors just because why not? We'll say it's an old Jeep and one door is messed up. Now suddenly we have the way we want it. But you can get some just kind of crazy, unpredictable results with mixins. It's not bad to use them. I don't want to deter you from it. It is an option. A lot of older programmers will stay away from them simply because they like the structure that inheritance gives, or they want to know what an interface is. They want to know that they have everything that's in the interface that you're providing, because an interface is a contract. Whereas a mixins, it's just kind of, Wild West. You just do what you want. So I hope you found this educational and somewhat entertaining. We're going to continue on with Dart. I'm trying to plow through these fairly quickly because I really want to get into Flutter. I really think that Flutter is going to take off in the next year or two, and I think it's going to be a major competitor with the other languages out there, especially things like React Native. So if you found this even remotely helpful, go ahead and visit my website and go to tutorials, and you can download. Hey everybody, it's Brian. Welcome to the 12th Flutter tutorial. We're going to continue our journey on learning Dart. Now, one thing you should know is that we skipped something here. We went from control flow statements to classes, and we skipped this exemptions. And there's a reason why I did that. A lot of tutorials out there will talk about exemptions and say, and exemptions are classes, but we'll cover classes later, which means you are completely mystified and confused by exemptions the whole time. I wanted to reverse that and talk about classes first. That way, during this tutorial, there should be zero misconceptions about what's going on under the hood, and we can actually work with the advanced code rather than jumping back and forth. So, without further ado, exemptions. Dart provides an exemption and error types, and there's a distinction between the two that you really need to understand here. So the exemption class is basically it's information that we are conveying, where the error class is an error object that represents the actual failure that we should have avoided. So that's kind of the distinction between the two. And Dart has a little bit of, a couple predefined subtypes, and you can actually build your own, which we're going to do in this tutorial. To do that, not just build your own, but to just handle errors in general, you have to know how to throw errors and how to catch errors. Think of it like playing with a ball. You ever play with just like a baseball or a football as a little kid, you throw it and catch it. You have to understand that program execution is very linear, meaning if at any time it breaks, your program will stop. I'm sure you've seen programs that have completely died. All right, so what we're going to do first is we're going to say, we're going to catch an error. Now, usually when you catch something, it's not a great thing, right? So we're going to say test A, and then we're going to print, and let's say, we're going to intentionally make an error here, just because I want to show you what happens. Now, if you see this, you can tell that somebody ran out of coffee. There was some issue going on. Not only is this not even a variable, but it's undefined completely. We don't even have a test class in here anywhere. So let's just run this and see what happens. First off, you can see the actual application is really trying to warn us, hey, bad things are going to happen if we do this. But if we actually just run it, you'll see that, boom, whole thing just explodes, and life as we know it has, ceased to exist. No top-level getter or setter test declared. The entire application just hard crashed. We can look at the stack trace here, and we can see, tracing it back up to here, this is the reason why. No such method error. Now, that's a keyword right there, error. We were just talking about exemptions and errors, and the error is the actual thing that happened. So, really what is going on under the hood here is there is no such method. And that's, kind of preceded by the error name here. So that's the typical format for errors. You'll be able to see, division by zero error, catastrophic failure error, blah, blah, blah. There's any type of error you can imagine, but that's really the naming convention. And we're going to make a custom error. Before we do all that, we're going to actually learn how to catch these things. So first thing we're going to do is I just want to print some things out here. Oops. This may look a little weird at first, but just trust me on this. Oops. All right, so this probably looks a little bit crazy, and we're going to go over this in depth because this is kind of the bread and butter of this tutorial here. And then we are just going to say done. So we know this is going to crash because it's got the same code in here. What we're going to do is we're going to wrap it around what's called a try, catch, finally block. So here's try, here's catch, and here's finally. These do three distinct things. Try will try to do something. For example, try to run a marathon, try to get a new job, try to find a wife or a husband or whatever you're doing, try to bake a cake. Catch means that an error was thrown and we need to catch that. Think of it like a big fishing net. It's catching the problem. And then finally does not care what happened up here. Finally is just off doing its own thing, saying, okay, I don't care what you two are doing. I want to do it my way. So if you want to execute code, and regardless of whether or not there was an error, you would put it down in finally. So let's run this. And you can see, sure enough, starting, trying, error, no such method error, same error. And then we've got our error message with the rest of it. And then tried, calling, test. And then finally we're done. And you could actually just, get this right here. Say, we just don't care about that error. See, error, don't care. So we're just going to keep going on. And our program finished with exit code 0, which means that it did not crash. It ran fully. It did exactly what we expected it to do. And life is good. Some things you should know about this, though. It is very bad programming to make what's called a silent error, meaning nothing happened here. Because if that error became catastrophic, it could potentially crash your program. So it's always good to either log or let the user know or do something. That's why randomly sometimes when you're using a program, you'll see a message saying error occurred, blah, 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 and you're like, I don't care, leave me alone, I just want to do my work. But that's the programmer's way of telling you, hey, something under the hood went boom, and you should be aware of this. So that is how you catch an error. Now we're going to actually raise an error. And this is actually a little funky if you've never done it before. All right, so we're going to do our try catch block here. If you're wondering what this E is, the E is an automatic variable. It's actually a representation. It's the error class, or the actual, I'm sorry, not the error class, the exemption class that's in memory. And we're going to show how to build one of those here in a little bit, but right now I just want to flesh this bad boy out, so bear with me here. All right, so we've got our try catch block in all of its glory. And we're just going to do some simple logic here. We're going to say if A not equal B, then throws a special keyword. And then do. Wow, that's bad when you misspell do. I'm still in a turkey coma. Yesterday was Thanksgiving and I'm just like not with it. All right, so we're going to catch the error. And right now this is what's called a silent exemption because we're not doing anything with this. So we want to actually fix this problem here. Something went boom, and we want to, just because, actually print out our error message and print complete. Completer, is that even a word? Completer. And let's actually just, while we're in here, fix the problem. Wow, I wasn't playing around when I said I was going to make a lot of errors in this tutorial. All right, so we're going to, geez, there's even another one up here. All right, so we're going to call this out, and let's just comment this guy out here. So we know that because those numbers are not equal, that it's going to throw this error. Now, if you look at that, you're going to stop and say, Brian, that's not even an exemption class, that's just a string. You're absolutely right. In Dart, you can throw any type of object you want. That will be, I think, under the hood, it gets wrapped into their exemption class and bundled up nicely and converted into a message. I think all it really needs is a toString function under the hood. All right, so let's run this and find out what happens. And it says something went boom, not the same. So that is how you throw an error. Now, why would you want to ever create an error? I mean, why are you intentionally doing this? It's simple. Sometimes you want to know that something bad happened and you cannot continue execution. For example, let's say you're trying to open a file, but that file does not exist. You would throw a file not found exception or a file not found error and say, hey, boom, file not found. A big ugly message pops up on the screen and the user goes, oh crap, wrong file name. So one thing you should also know is that you can actually cascade error messages. So let's make a void internal. And we're just going to say throw nope. Program just doesn't feel like working today. And in here, we are going to just call the internal. And let's see what happens here. Let's comment this out. Now, when we run this, boom, it crashed. So we're calling outer, as you can see here. Outer's calling internal. Internal actually throws the error. So you don't actually have to catch the error where you're throwing it. That is where some tricky programming comes in. Because you never know where an error is actually going to come from. So that is how you would actually catch that. See? Program failed. What I'm getting at here is sometimes you'll use classes and libraries and things that other people have built, and if an error occurs or an error is thrown, you may have to actually catch those. So you may not know that the error could potentially exist, but you're going to have to deal with it at some point. And that right there can get to some real headaches. And that's actually one of the biggest reasons why programs crash. It's you rely on somebody else's code, you're not fully comprehending what's going on under the hood, and then problems ensue. All right, so let's just say we want to create our own error object here. So we want to implement the exemption class, and we want to just kind of flesh this out. Say final string, we want a message. And we're going to make this optional just because. We're going to override this. Whoopsie. Fat fingered that one. Very simple. I mean, very easy. You can make this extremely complex. We've had our conversation about classes and flow control, all that. You can do a whole lot of stuff in here, like maybe a custom thing you'd want to do is dump this to an error log. Maybe you would want to pipe it out to a website. Maybe you would want to take corrective action and fix something or pump something out to a database table. But for this example, because we haven't covered most of that, we're just going to make it very simple, very easy to work with. So we have our color error. Let's close that, close that. So now we're going to import our color error. And we are going to make one horrendous, ugly looking piece of code here. Now I did promise we would cover enums, so let's actually, without further ado here, whoops, we're going to make an enum and we're going to call it color. There's a reason why I didn't make an entire tutorial just on enums, because they are just dead simple. So an enum is basically a enumeration of something, an enumeration of values. It's a zero-based index, so this is 0, 1, 2, and it's super simple to work with. And we're going to say void cats because I like cats. Then we're going to say color, and let's call this color. Notice how the upper and lower case are two distinct things. And we're going to say try. And then we're going to say catch. And finally, now here we're going to actually check. We're going to say if color not equal color dot, and then notice here's our enumerated values. And the values is actually in there as a function. You can get a list of colors. We've talked about generic programming a little bit at a high level. It's going to be probably actually the next tutorial. But you can see how we have a list of colors, much like in the past we've had a list of strings or integers. So if the cat is not black, then we're going to say throw new, whoops, cat error. Why are you not picking that up here? Oops, it's not cat error. Geez, color error. Told you Thanksgiving got me all messed up. Must be black, because black cats are pretty awesome. Some people think they're bad luck, but I had black cat for years and years. He was probably the best cat I ever had. And then we are just going to leave it at that. And we're going to say print So if we do a brown cat, why not? Everybody likes brown cats. Run this, you can see that unknown error must be black, and probably would have done that. So we can see that nothing really happened here. Let's actually just pet the cat. Whoops. Let's run this again. You can see how pet the cat never gets printed because we had the unknown error of must be black. Now, this is a problem. Why is this an unknown error? We actually know it's an error because, well, we threw it. So what we're going to do here is we're going to add another called on. Oops. We're going to say on color error. And what we're doing here, whoops, we missed a little bit of verbiage here. We need to do something with that. So on color error, catch, there we go. We're going to catch the exemption. And then we're going to say print, you selected the wrong color. So what we're really doing here is we're saying, hey, we want to know that Brian is horrible at spelling. We want to know what type of error. And so you can actually create your own error types here using error classes. And let's actually make another error here just because. And we'll say cat A. And we'll do our faithful little error here. There's no cat type, therefore, we know it's gonna extremely explode here. And that would be a programming error anyways. So you selected the wrong color. Let's actually make this black. Now our little program should work, meaning it should pet the cat, but then we've got this guy right here. Let's see what happens. Bang, suddenly we get an unknown error. So that is a good example of a couple things. A, how to use an enumeration or an enumerator. B, polymorphic programming. We see that this algorithm does two distinctly different things based on the input, and how to use custom error handling. It can get much more in depth than this. You can make just dozens and hundreds of these. Typically what I do is I will write a function, and then in every function, especially production quality code, will immediately be wrapped with a try catch finally, and then I will put my specific error cases exactly how you see in this tutorial. That way, if I expect, like file not found or disk space full or something like that, I know exactly what happened. And then I always have a catch-all at the end. That way, if something completely out of left field happens, my program doesn't crash. It just says, hey, unknown error occurred. So that, in a nutshell, is error handling. I hope you found this educational and entertaining. Be sure to check out my website, voidrealms.com, for the source code for this and all other tutorials that will be out in GitHub. Hey everybody, it's Brian. Welcome to the 13th Flutter tutorial. We're going to continue down our Dart learning curve here. We have to learn the Dart language before we can work with Flutter. And we're going to talk about generics today. And we've actually worked with this before. Whenever we made like a list, like you can see this little snippet of code right here. And it's actually has the arguments in every single program we've made so far. So we can do something like list. So I had that E, so we have to define type. And we'll say things, new list. And then we can add things in there. Now, we could have also said string or bool or whatever we wanted to do. So why do we need generics? What's really the value here? Well, let's say we wanted to make a function, and let's just say void add. And void, we want to just take something, let's just say a string, and we want to just add it. So let's actually come back here. Whoops, not string buffer. Jeez. All right. We just want to add it here. So we're going to say return value +1. But now let's say we want to take the same thing and we want to do it with integers. So now we've got to rewrite this whole darn thing. And now this isn't a string, this is an int. And you can see how now it's complaining that it's already defined, and so now we got to turn this into add int, and then turn this one into add string, and then we'd have to know which one to call, and you can see how it gets very confusing very quickly. So yeah, we're not messing with any of that nonsense. What we're going to do is we're going to use generics. And what generics allow you to do is they allow you to actually take the type and turn the type into a variable, if that makes any sense whatsoever. And we're going to actually discuss this, but if you read through their examples, they're actually very helpful and very insightful. I went through that section in probably about 10 minutes. It was super easy to understand. So we're just going to dive right in. And we're going to say log. Now we want to put these little arrows here. That means anything in these arrows is going to be a type that we're going to use for generics. And we can use that in our program now. And we're just going to print value. So what effectively have we done here? We've said, hey, we're making a method called log. We want to use generics, so we're going to have a type. That type will change. That's what I mean by that's a variable type now. So that type will change. And here's our actual variable, which is going to be of whatever type we shove in here. And it's just going to print it out. Print takes an object, so it won't actually freak out on us. So now we can say print, we can say hello Or we can even say print and some number. And they both work. See? Down here we've got hello and then whatever number that is, giant long number. My laptop made some weird noise. That kind of scared me a little bit. It's kind of like Godzilla. It was weird. Anyways, so that is a very super simple example. We can now put anything we want in there. So let's say we want to actually restrict the type. Let's go back to our addition. We're going to say add, and let's say t extends. And we want to extend the number class here. Now we're not doing inheritance here. That's the confusing bit. What we're doing is we are saying that anything of the t type has to inherit from the number class. Now when I say the t type, I mean this guy right here. So anything that we put into this has to inherit or extend the number class. So let's go ahead and finish this out. We're going to say return value +1. So what we can say now is print. We're going to say add. I'm just going to say 1. And this should print the number 2. And there it is, number 2. So if we take this and we now try to do something like this, you can see how it's already mad at us. It's saying an argument string cannot be assigned to the parameter type num because it knows it has to extend the number class. And if we try to run it, of course, it just explodes on us and says, nope, can't do it. And it even tells you why. Type int is not subtype of string or other where, and then it just shows you. So that is one way of limiting that right there. So let's get a little more complex here. Let's actually work with a class. And I know I say complex, but this is actually just dead simple to work with. And I'm almost embarrassed making a tutorial on this because it's so easy to work with. Other languages, generics, get very complex very quickly, but Dart makes it very simple. I think they kind of borrow some of the best parts of other languages, but that's just my humble opinion. So we're just going to have a dog class. The dog's going to speak, and then we're going to make a new class. We'll call this stray, which is like a stray dog kind of thing. I'm going to import the dog class. And this stray is really not going to do anything. I mean, we're not going to have any properties in it. And then we're going to make a trainer class here. And we're going to import the dog class because we're going to be working with that. And we're going to say class trainer, and we want to have our generic type in there. And in here we want to say, okay, void add, and we want to have our t value. And whoops, I missed a step here. It doesn't make much sense what I'm doing if we don't have this. So what we're going to do is just make an internal list here, and this is not uncommon for a lot of programs. All right, now this will make a little more sense what we're doing. Then we're going to fat arrow this into animals, add, and we're just going to add the value there. So we're going to be able to add, remove to that internal list, and then we're just going to say void train. And if you have no idea what I'm doing here, I encourage you to watch my previous tutorials. We're just going to do that, and then we're going to say for int I equals 0, I is less than 3, because why not? and then going to increment. So now we're going to say value.speak. This looks weird. Let's talk about this. Okay, so what we're doing here is this is our generic class. The dog is just a normal class. The stray just extends. Whoops, we actually didn't even do that. Extends the dog class. And then the trainer itself is just a generic class. Now, when I say generic, I mean it's using this. And you can see internally we're using this list, and we're actually using the same type. And we're just going to add and remove values to that list, and then we're going to work with that list. Now you notice how instantly it's saying the method speak isn't defined for class object. What does that mean? Well, it means that we actually have never defined this. We haven't said what it extends, so it's going to automatically extend the object class, which is the base class for pretty much everything in Dart. The base class object does not have a method called speak, which is why it's saying, ta-da, object doesn't have that method. Now, let's try to work with this and just see what happens here. And let's say, and whoops, I don't want dog, I want stray. Now we are going to make, you guessed it, a trainer, and we're going to say, I'm trying to think of a good name. That's why I'm like sitting here for a minute going, let's say stray, and let's call him, why not? Let's call him Bob. And then let's do this. Oops. Bob.add. We're going to add Fido into this. So Bob's going to train Fido, basically, is what's going on here. So we are adding Fido. We're going to train all the dogs in the list, and then we're going to remove Fido because Fido has been trained. And let's see what happens if we run this. And it says, woof, woof, woof. So now back up. Wait a minute. What's going on here? Notice how we've done a couple things. We haven't added the generic, or we haven't added the type in here. But Dart was smart enough to know that because it's here, we're doing it. Also, in the trainer class, it's still saying method speak isn't defined. This is a perfect example of what's called polymorphic programming, which means that your program changes based off the input. If we were to put a integer in here, it's going to die because integer doesn't have a speak in here. And let's actually try that. Let's say let's say 1 and 1. That's probably not going to work, but let's try it. Yeah, see, boom. Class int has no instance method of speak. So the same code did work, but didn't work. If you kind of follow what I mean, it works for what we programmed it for, but it didn't work for integers. So what we need to do now is go back in and modify this a bit. And you guessed it, we are going to say extends the dog class. Now suddenly it clears up and it knows that, hey, dog and anything that inherits from or extends from dog actually has that. So now this should just work fine. Woof, woof, woof. There we go. So just some little caveats is you should be a little careful with generic programming. It's a bit of an advanced topic. A lot of questions that I get when I talk about generic programming in other languages is why? I mean, when do you actually use this? You'll see a lot of generics in core libraries, things like lists, for example. So if you're making a program that takes plugins, for example, you would have a base plugin that all other plugins would extend or inherit from. And in your generic programming, you would, just like we did with the trainer here, you would extend that base plugin. That would be a really good example. Another thing would be like if you're making like a music player, you would have a generic class called song or file or whatever, and everything would extend upon that, and then you would have your base methods in there. So another question I always get is, how do you have more than one? Like there's T. What if you wanted like a couple? You just simply separate them by commas like that. We have E and H in there. Now we could use E and H, but then you have to, in our file here, you see how they're suddenly exploding. We would have to say int and string, and they would have to match up. Whoops, probably help if I spelled string correctly here. Yeah, really screwed that one up here. Sorry, guys. And then you would have to, obviously work with the extra types as needed. But I'm going to get rid of those because I don't want them to be part of the example here. Just remember that generics are a bit of an advanced topic. And really, it's a powerful tool. The problem with a powerful tool is that when you hit yourself in the foot with it, it's going to hurt a lot worse. And you'll get some weird errors like this value speak. Like if we didn't extend dog, if we just let it extend object automatically, and we throw the wrong value type or the wrong variable type in there, suddenly the program starts crashing and we're trying to figure out why. So just be mindful of that. As always, I thank you for watching. I hope you found this educational and entertaining. There is a Void Realms Facebook group with 1,700 other programmers out there. We can help you with just about anything you need. Very good group of folks. I'm constantly asking questions in there, and the source code. Hey everybody, this is Brian. Welcome to the 14th Flutter tutorial. We are getting into the advanced Dart topics. Remember, we have to learn Dart before we can really dive into Flutter. Today we're going to talk about asynchrony support or asynchronous programming. What in the heck is this? That is even a mouthful to say. I'm sure everybody listening to this has had somebody tell them, hey, do this, but while you're doing that, also do this, and then maybe do this, and this. It's really multitasking. Asynchronous programming is different than multi-threaded programming under the hood on how the computer actually works with the code. Won't get too deep into that, how that works, but just understand that asynchronous programming allows your code to run asynchronously, meaning at the same time as your other code. And you can do some really cool stuff with this. So let's just dive right in here and let's create a new project. And next, let's call this multitasking. May help if I pull my keyboard out a little bit here. And honestly, I wasn't really going to cover this because I'm kind of chomping at the bit to actually get into Flutter, but it is a part of Dart and it's going to be heavily used. A lot of the I/O functions work with futures and streams objects. And in the words of Ripley from the movie Aliens, you started this, show me everything. So if you haven't seen that movie, it's like one of the best movies of all time. Anyways, let's just dive right in here. Now, if you've never worked with asynchronous programming, reading the official Dart documentation can be a little bit confusing and not really for the faint of heart, although it's actually broken down very well. It's just a very complex topic, and it's a very advanced topic, and even seasoned programmers make some very bad mistakes. So I apologize in advance if this tutorial has some mistakes, and I'm sure everybody on YouTube will point them out. I have to chuckle when I say that because they do point them out. All right, so the first thing we need to do is we need to import Dart async. And you notice how that has Dart : async. It's in the past we've done just a raw import. We import a file and we've imported libraries and stuff. But Dart, whenever you see that Dart : that means it's part of the core framework, if you will, or the Dart libraries. Now, I should note that everything in Dart is a library. Even this program we're working on now is a library. But that is how you import something directly out of Dart. So we have to kind of understand some things before we can really dive in here. So I'm going to start with a very simple example. And we're going to call this future. And notice how that took a generic type, which we just covered in a previous tutorial. We'll call this the long wait. All right, so already we notice some big differences here from what we've worked on in the past. Let's just finish this out real quick. Int I equals 0, I less than, let's just say 5, and then I plus plus. So we're going to increment that. And then we're going to just print out the prefix and the current number. And then at the very end of this, we're going to just return true. Some things you need to understand what's going on under the hood. A, you cannot use async without this import. You will get a glaring mistake here. Let's just cut that. See how suddenly undefined class future, and if I take that out, that'll start lighting up. And so first step is you've got to import the async library. The second step is that your functions and methods will have to be treated a little bit different. I keep saying functions, but they're actually called methods. They're treated a little bit differently. You won't actually return a Boolean. You're going to return what's called a future that wraps around the Boolean value that you're returning. Now, what does that really mean? You have to do that because of the way the code is actually executed. And let's just do this. Let's say and then we're going to print, whoops. Nothing too snazzy about this. It looks like it'll just run, right? So let's actually grab this and run it and see what happens here. Notice how it says starting done, then it says 0, 1, 2, 3, 4. Now wait a minute. If we look at the code, it says print do this, which is actually this guy right here, then print done. But if you notice, it's saying starting done. So it's going from here to here and skipping this guy altogether. It's not actually skipping it. It's doing it in parallel. This just takes longer to execute than this print statement does, so that's why it says starting done. But it's actually happening asynchronously, aka pretty much at the same time. Now, as you can imagine, that can lead to some very big problems if you're expecting things to be in a certain order. We're going to cover how to do that. But I wanted you to understand that we're not actually getting the Boolean value. We're getting a future, meaning we're going to return a Boolean value or whatever we put into this generic template here. So to get that Boolean value, you have to say bool ret, whatever we want to make it, equal. And we're going to use the await keyword. So what this will do is it will say, hey, this is an async function. You have to be in an async function to call an async function. As crazy as that sounds, it just needs to know. Let's actually test that. Yeah, see, suddenly await lights up and says, not going to run. So you've got to be in an async function. And the await keyword will actually, well, pretty self-explanatory, it will await this to be completed. So it's going to say starting. It's going to await for that to be completed. Once that's done, it's going to unwrap that future object. It's going to get that little value there and shove it into this one right here. Shove it right into that variable and then hand it off to our program, and then it'll say done. And we're actually not really using this, but I kind of wanted to show you how to get the variable back out of there. So let's just print this out. Just so that you can see there is an actual value and not a future object. See, now you can see how it says starting, and then we've got 0 through 4, and then the Boolean value, and then we're done. So that is how you would work with that. Now, there is a bit of an easier way. I say easier. Some people love it, some people hate it. It's just personal taste, really. Void, and we're going to say test then. Man, this keyboard's really ticking me off here. Yes, in case you're wondering, it's the same keyboard I was having problems with a few weeks ago. All right, so we're going to go starting. And through the magic of copy and paste here. Pretty much same structure. We are not using the async keyword here. So we're in what's called synchronous code, and we want to run asynchronous code. Well, we have two options. We either turn our little function into an asynchronous function like we've done before, or what we can do is and we want to say then get in there. And this will take a little bit of explaining. And this is why some people love this and some people hate this. Let's actually shove this in here and see what happens. All right, so when we run this, you can see how it says starting done. So we think that we've already screwed up, but then it says 0, 1, 2, 3, 4, done waiting. I left this done in here so that you could see what would happen. It will actually treat this as synchronous code, meaning it's going to do the then. Now, I understand that makes no sense. What does it mean by do the then? Code execution starts here, says do this long wait, it goes up, evaluates this, and says, oh, it's an async function. Good, I can just run this in parallel. So it's going to asynchronously run that. While that's running, it's going to jump down here and go, okay, we're back into synchronous code. So start, done, and then this executes off to the side at the same time. That is where the then method comes in. What then does is it says, do the asynchronous code, then when you're done, run this code. That gets a little confusing. Some people love that, some people hate it. Personally, I prefer this method because it's very clear to see what's going on. However, you can do some really cool things with this. So let's actually do this. And we're going to just say, oh, let's just grab this whole thing rather than type all this out. I'm getting old and cranky here, so. All right, so now what we've got here is, let's actually do this a little differently. So we're going to grab the future object out of here. Notice how we're not grabbing a boolean, we're grabbing the future object. And from here, we are just going to say, let's run this and just make sure this works as expected before we really dive into it. All right, so it's starting, done, and then we've got chains, blah, blah, blah. So what we're going to do here, and this is where I always screw up, and that's why I wanted to kind of do this, is we're going to grab this, and we're going to say bang, bang, done, chain 1, chain 2, chain 3. So let's run this again, see what happens here. Now you can see how you can actually say, hey, once you're done, do chain 1, do chain 2, do chain 3. So you can do things in a specific order after the asynchronous code executes. So this could be like calculate the sun, moon, and stars, and then put it into a database, and then log it, and then dial into a server and spit out some value or something. So you can do what's called chaining, and that's why I said chains. Let's just get rid of chain here and just say done 1, done 2, done 3. Done, done, done. Anyways, that was lame. If I edited my videos, I would edit that right out of the video. That was really lame. So now what we're going to do is we're going to actually test waiting on multiple asynchronous calls. And this is pretty advanced, and this can get kind of nuts. But the syntax for it is just dead simple. That's why I'm going to add this in here. And notice how we are back to the async. And we're going to say print and we're just going to say future f1 equal kind of just copy and paste this a few times here. So we've got our 3 asynchronous calls here, and let's actually comment this out so we can see it work in real time. And you can see how there it goes. 1, 2, 3. That is how that's going. Now, this does not necessarily guarantee that it's going to be in order. It may not be 1, 2, 3. These are each independent, distinct calls. So it may be 2, 3, 1 or 3, 1, 2 or whatever permutation here. So what we want to do is we want to know when all 3 of those are actually completed. You see how we got starting done. We want done way down at the bottom here. So what we have to do is we have to say await future, and then future itself has a wait call in it. And notice how it wants multiple futures. So we're just going to, you guessed it, we're going to wait for those. And once they're done, it'll print it out. Bang. So starting, and then there's 1, 2, 3, and then done. That's pretty neat. So just be aware that there is a lot of code, especially I/O code, that is synchronous, and you'll have to really learn how to work with that, but it's really not that hard. To be brutally honest, some other languages, the syntax in like JavaScript, for example, is very similar, but for whatever reason, JavaScript makes me want to just rip the keyboard out of the wall and throw it across the room. I don't know why. Dart, however, is very streamlined and very elegant. I really like the way it works. So that, in a nutshell, is asynchronous programming. It is by no means the lexicon of asynchronous programming. This would be just like a high-level primer, just so we can start working with Flutter. You will run into issues, and you may have spotted 1 or 2 bugs in this little program here. So if you find the bugs, definitely go out to GitHub, modify the source, commit it, and I will approve it. And we'll go on from there. Speaking of, if you found this educational and entertaining, visit my website, voidrums.com, for the Hey everybody, it's Brian. Welcome to the 15th Flutter tutorial. We're going to continue on our learning curve of Dart. We're actually getting towards the end of this here. If we go ahead and jump into language and then do a tour of Dart, you can see that we've covered pretty much all of this. Today we're going to backtrack a little bit and go back into classes a little bit here. I want to discuss static, my brain just shut down, static methods and static variables inside of classes and how they actually interact with Dart. So let's just go ahead and crack this open. We're just going to call it stat. I like that word, stat. So if you are from another language, you're probably rolling your eyes going, I already know how this works. There are some minor caveats. If you're brand new to programming, this may completely blow your mind, and I apologize in advance. So we're going to just kill that, and the first thing we're going to do is we're going to make a new class here, and we're going to call it counter. Now in the counter class, we're going to make a private variable here called static int. Well, let's call it count. So what does a static mean right here? Static is a keyword. You can tell it's a keyword because it's highlighted in bold. Really what it means is it exists throughout every instance and non-instance of that class. And we'll really get into that here in a second, but just understand that it means it always exists. So what we're going to do is we're going to say int get. We're going to make a getter and setter for this. I swear my phone is dying. It just made the weirdest noise. Now, why am I making a getter and setter? We really don't have to. I'm just doing this to show you that, you can have this as a private member variable, but also have it static. Some people get a little confused and think that just because it's static, it has to be public, and it really doesn't. So now we're going to make some static methods here. So we're just going to increment and decrement respectively. And then we're going to make some non-static methods here. And actually we can just shorten these up as well. I don't know why I was going to do it this way, but oops. And then so we can add and remove 10 respectively, and then we are going to just print the count out. Now, you may be looking at this and asking some questions. What is static? Why is it all scattered throughout this? And how come we're using count and not the getter and setter? Well, remember, getter and setter are primarily used for outside of your class. While you're in your class, you have the inner scope, and therefore you can access this internally. Everything outside of this, because this is a private variable, will not be able to access it, so you have to use the getter and setter. And now we're going to go over to our main file here. We're going to import the, oops, man, that was a major fail right there. That was kind of embarrassing. So first thing we want to do here, let's just say counter, and you notice how if we just type the class name counter, we have the decrease, increase, and print count. And if we look at the class again, you can see that increase, decrease, and print count all have static. That's what it means, is we don't have an instance of this class, yet we have those functions, or I should say those methods. And we can actually work with those. So we don't even have an instance of this, but yet still it works. We've gone from 0 to 1, and we can actually increase this a few times if we want. Now, one thing you should notice is we don't have access to the non-static fields, and that is simply because they're not static, meaning you have to have an instance of that object. All right, so we're going to say counter obj, just short for object. And you notice how now we have access to the non-static fields, but we do not have access to the static fields. So we have access to add 10, but we don't have access to increase or decrease. Whoops. Boy, screwed that one up. And this is why we're using our getters and setters, so we can access those. And we're going to dereference that object. And once again, we're going to print the count. So what we're going to do here is we're accessing the static fields, and then we're going to make an instance of that object and modify it with an instance of that class. Or instance of that object, that doesn't make any sense. We're going to make an instance of that class, we're making an object, and then we're going to modify it using the non-static fields. And then we're going to actually print the count out again, and we can see how the count actually increments. So we've got 0, 2, because we've gone from 0 plus 1 plus 1, so there's our 2. And then we have gone to 12 because we've added 10. And then we've set it to 5, so there's our 5. And then we've set it to null. We set our object to null. But yet we can still print out 5. And if we made another instance of this class, let's call this obj2, so we know it's a completely different object. Let's get rid of that right there. You can see that it stays at 15 because now we've added 10 to the 5. And even though we've set this to null, it still stays there. So that, in a nutshell, is static fields. Now, one thing you should know is you don't always need static. A lot of people think I need to convert this to static and that to static. You really don't. Many times what you would actually need to do is persist this off to a storage device somewhere rather than actually holding it in memory. For a counter, it would actually make sense. Like, let's say you were building a humane society that houses animals, and you want to know how many animals are in there. Every time an animal is added or removed, you would increase the counter. But for normal lists and things like that, static really does not make a whole lot of sense. What is a good use case for static? Well, this right here, actually. If you want to make what's called a utility class, or a class that has a lot of functions in it, or methods in it that you would just use throughout the day, rather than having to actually build an instance of that object, you can just say class dot whatever it is, and then you've got all your built-in functionality. There's actually a lot of libraries that do that, so that's a good use case. That's all for this tutorial. I hope you found this educational and entertaining. The source code for this and all other Hey everybody, it's Brian, and welcome to the 16th Flutter tutorial. We're still on the Dart learning curve here. We've covered quite a bit, but what we need to do now is if you scroll all the way down here, you can see there's libraries and visibility, and I wanted to talk about this a little bit here. In Dart, everything is a library, including the programs that we've made up to this point. There's a distinction in how those libraries are actually set up and how they're used, though. Another distinction is whether they're internal to Dart. They start with the import Dart semicolon, or whether they are packages that are not included in Dart itself. There is a lot out there, and to be brutally honest, there's some of these features you may never actually use. You can import a package as a variable. You can actually show only specific parts of a package and hide specific parts of a package. You can even do lazy loading of a library, meaning you can have this massive library and only load the pieces you need as you need them. It's actually a really cool feature. They don't really cover it a lot in the tour of Dart. You have to actually click on libraries over here, and you can see there's a tour of the Dart libraries, commonly used libraries, and then a whole tutorial on how to create your own library packages. We're going to cover a little bit of this, but I wanted you to be aware of this for future tutorials here, that when you click on that, let me back up in case that wasn't apparent what I did. You click on Tour of Dart Libraries, and you can see they have got just a ton of information of all of the built-in functionality with Dart, and their slogan is batteries included, which I think they kind of took that and plagiarized that from Python. I'm not sure which one came first. I'm pretty sure it was Python. But anyways, it is actually batteries included. There's a lot of bang for your buck in here. One of my favorites is they have, browser-based apps. They have I/O, they have conversion, and they have mirroring, which is reflection. So it's really nice to have this right into the library itself, so you don't have to go and get something external. However, back here, you should be aware that you can actually make your own, and you can publish it out on this thing called pub.dartlang.org. Now, if you're wondering what it's pub is a tool for managing Dart packages. And if you go out to pub.dartlang.org, you can see there is a lot out here. So let's say we want to, and I'm just going to pick something at random, image. You can see there's image pictures, Flutter image, zoomable image, image carousels, image transformers. Okay, let's try something a little more specific like resize. All right, so here's a good one. Provides a server and web apps with the ability to load, manipulate, save images in various image file formats. And you can see it works in Flutter, it works on server, and it works on web. So we actually just click on this, and it gives you a brief rundown. And not all of these are created equally, mind you, but some of them have a lot of documentation, some of them don't. You can see the author. This was not an official Dart package. And you can see that it has no reliance on Dart I/O, so it can be used on both server and web applications. You can read-write all of these formats, read only those, and it has all of these functions built in. And it has changelog and how to install and how to use, which we'll cover in a future tutorial. But for this tutorial specifically, I wanted you to know that that functionality exists. Just know that there is a massive amount, and it's growing daily, of libraries out there for you to use. And just about any functionality you can think of is already out there. And it's, I mean, as you're listening to me speak, it is continuing to grow and grow and grow. I've heard a lot of programmers say, oh, Dart is dead, don't work with Dart. I've actually seen it grow right before my own eyes, and it's kind of crazy. So let's dive into this one. We're going to make our console app. We'll call this lib intro. Why, I don't know, just because I couldn't come up with a better name. All right, so now that we have got this, a little bit of explaining what's going on here. You can see how we have this folder lib and we have this folder pub. When we use something out on the public, i.e. in pub Dart, it actually goes in here. And you'll see that in future tutorials. What we're going to be working with is right here and in the built-in libraries. So let's actually expand this. And this is just boilerplate. This comes with every single application that we've made to date. And you can see how it says import package, semicolon, and then it has the path libintro / libintro.dart as, because we're importing this as a variable. And then we can, down here, libintro.calc. And we can import this as pretty much anything we want. I mean, we could say cat. And then it will calculate using the function out here. And we've talked about this before, how we can add things in. It's a pretty strong feature to be able to do that. You can structure this pretty much any way you want. There are some caveats. One thing you'll have to have, and we'll cover this when we actually build our own library, is you'll have to have this pubspec YAML. Which just has some details into it. All right, so what I wanted to cover is the differences here. So let's actually work with a built-in Dart package here. So let's say local notice how I'm starting with Dart semicolon, and you can see all of these that it come built in. That's pretty crazy, right? We've worked with a sync before. So what we're going to work with is called convert. Convert really has some pretty nice features to it, but what we're going to work with a little bit is called JSON. If you don't know what that is, it's a way of stringifying, I guess is a good way of putting it, an object so that you can work with it. Some people like XML, some people like JSON. It basically takes an object and makes it into a giant string or variable that you can pump off to the network, read it into another program, and convert it back into an object. So we're going to make a map, and we're going to say string int And then we're going to say map dot put if absent. And what we're going to do here is we're just going to say put my age in here. And now I feel old. I feel ancient. I play Call of Duty, and these kids like mop the map with my face. And we'll just throw my daughter in there. So what we're going to do now is we're going to actually convert that object into a string. So we're going to say string encode, and we're going to encode the map itself. Then we're just going to print this out. And you can see there's the JSON right there. That's the string representation of that object. So now we want to convert this, well, from a string back into an object. So we're going to say map string int. And let's call this people, so we know that we have a different object altogether. And we're going to take that string and decode that into an object. And we're just going to say people for each, and then we have our key value pair. Maybe that was kind of bad. We have our key value pair. And we're just going to print that out. So really all we're doing is we're taking our map, our object, using JSON to encode it into a string, and then using JSON to take that string and decode it back into an object. And you can see here's our JSON, and here's our actual decoded object being printed out in the for each. So this seems like a very simple example, but it really shows you just how powerful Dart is. Not so much that it can do JSON encoding and decoding. Other languages can do that, obviously. But the fact that you can very easily add this functionality right into your application without jumping through a lot of hoops like you have to with other languages. Sometimes you'll have to import this, do some local build, do some extra steps, do some configuration, Most of the time, it's very simple, very easy. And I think in future tutorials, probably actually maybe the next tutorial, we're going to actually show how to just grab something random off of pub.dartlang.org and show you how to leverage somebody else's code. I may have to actually, well, it's not that I may, I'm going to definitely have to test a few of these that make sure they actually work as intended. But I mean, as you can see, just about anything you can really think of, like let's say you want to do a server. Let's look out here. Okay, so there's all different types of TCP servers. A web server, here's a multi-server, web server middleware, ICU server. Let's just pick something completely random here. Let's say IRC. There's an IRC library out here, IRC client. I mean, as you can see, there's just a lot out here, and I hate to sound like a broken record, but it's continually growing. So it's very important that you learn how to work with this, because a lot of the times you'll find functionality that you need already exists, and rather than reinventing the wheel, you're going to have to import the code and actually work with it. Well, that's all for this tutorial. I hope you found this educational and entertaining. Once again, visit my website, voidrealms.com. Hey everybody, it's Brian. Welcome to the 17th, I better double check that, 17th tutorial with Flutter. Got a little frazzled there. My phone was kind of beeping in the background. Anyways, we're going to continue on down our Flutter tutorials, and we're going to learn a little bit about I/O. Now, when I say I/O, I don't mean the moon I/O. I mean input-output. And the first part of input-output we're going to work with is called files and directories. Files and directories is a huge topic, and we're going to kind of condense it down a little bit. So obviously we can't cover every single little use case, but we're going to cover the vast majority of them. We can't cover everything because we will be here for 300 more videos. You can do just about anything with files. You can encrypt them, decrypt them, encode them, decode them, pump them across the network, scramble them up, chop them up, dice them. I mean, whatever you want to do. I hate to sound like an infomercial, but files are quite literally the bread and butter of most programs. So, without further ado, let's go ahead and import Dart convert, Dart IO, and let's work with this. So the first thing we want to do here is, let's say we want to figure out how to list files and directories in a path here. So we're going to say void list. I hope if I actually did that correctly. And we first want to surround this with a try-catch block. Now, why do we want to do a try-catch block first? It's because working with the file system can be very error-prone. If you've ever worked with an older OS or a computer that's kind of flaky, you'll know that really quickly, that sometimes files just do not play nice. All right, so, whoops, equal new. All right, so what we've got here is we've got a directory object, and we're just going to make a new directory object based off the path. Then we're going to say, now if you notice how we can say exists and exists sync. This is kind of the crux of the IO portion of Dart. IO is asynchronous, so what they've done is they put some helper functions in here that allow you to help you call this synchronously. So instead of doing exists and then messing around with await and then and futures and all that, we're just going to do these sync and let them do all the heavy lifting for us. So if it exists, then we're going to get file sensitive entity, and we want to list sync. And then we're going to just print out so first thing we want to do here is actually, let's get a listing here. So we'll see. We're just going to, I'm on a Linux system, so we're just going to grab the root path. Users, you might want to do that on your C drive. Let's just run this and see what happens here. You can see how we get a whole list of things. This is everything that is on my root path here. If you know Linux, it's really nothing special on this virtual machine. All right, so whoops, I gotta pause the video for 1 second here. Sorry about that, somebody was at my front door, so I had to go see what it was all about. We're gonna change this path here, and it's just the path that I have the videos in. That way we're working with a very small section of my file system, so if I goof up, I'm not reinstalling my operating system here. Although on Linux it's really hard to actually blow something up. But you can see how we actually have a different structure now, and this is actually the movie that we're creating at this very point in time. So what we want to do is we want to learn how to write to a file. I'm going to say bool, and this is just the way I do it. There's the problem with programming, or I should say the added bonus with programming, is there's literally billions of ways you could do this. I'm just doing it my way. If you don't like it, feel free to do it your way. But this is typically what I do when I'm writing a program. All right, so we're going to do the try catch block. Whoops, we did screw something up here. Now, if you're wondering why I'm doing just a print toString, it's because I want to know when something actually blows up. The last thing you want is what's called a silent error, which means you have a catch and then you don't do anything with it, because then you run your program and nothing happens and you're like, what the heck? So you want to know that there was actually an error, and that's why I just print it out. But all right, so we need to say file. So we're just saying want the file object to be a new file based off the path that we're giving it. And I probably should name this to path, but I'm just going to leave it as file. And then we want to say a random access file. I'm going to call this rf equal new random access file. Actually, nope, sorry, I screwed up. We want to get that off of our file reference. Sorry about that. And we're going to say open sync. Now you'll notice that there's open read, open, which gives a future, and then open write and open sync. We're just going to work with open sync. There's different types of files. We're going to work with what's called a random access file, meaning we can randomly move around in that file and do whatever we want with it. I typically work with random access files because they're a lot more flexible, although they are a bit slower. Technology has grown to the point that the difference between a random access file and, say, a sequential file is very minimal. And then we want to actually give it a mode. And the mode here is going to be the mode that we give the function, or I'm sorry, the method. If you're wondering what the mode actually means, you can actually say file mode dot and see the different modes. There's append, there's read, there's write, write only, and write only append. Append basically takes an existing file, if it exists. If it doesn't exist, it creates it, but let's just say it exists. And it just keeps adding to the end of it. Think of it like a line in the bank. It'll just keep adding to the end of it. Read will read from the file. Write will completely destroy the file and write it from scratch. Think of writing as, you take your parent a bad report card, they wad it up into a ball, throw it in the trash, and say, bring me another. Write only means you can only write to the file, and write only append is pretty self-explanatory. You can only append to the file. Why they didn't call it append only, I don't know, but all right, so those are the different modes, and that's pretty standard of most operating systems, regardless of what platform you're on. That's kind of like a file primer. You probably spent a week talking about that in your computer science class. All right, so what we want to do now is we want to write string async, and we're going to just say data, and then we want to flush sync, and we want to close sync. So flush and close, those are real keywords. Kind of ignore the little sync at the end here for now. Sync just means that we are asking Dart to do this synchronously. Focus on flush and close. What flush does is think of a file as, well, like a toilet. I hate to say it that way, but think of it like a toilet. And you're just dumping stuff into it. And when you're done, you want to flush that toilet and write it down to the disk. So flush literally tells the operating system, hey, write it down to the disk. Close then closes the file. I am not 100% certain, but I think under the hood, close may call flush for you. I know on some different languages it actually does. I'm not sure if it does in Dart. So I'm going to call the flush intentionally because that is what was out in the actual code they had as an example out here somewhere. I'd have to find it. Yeah, right here. Writing file contents. I think they're doing this because their example is asynchronous and I'm doing it synchronously, so I'm not sure if I actually need to do the flush. I think I just need to close. All right, so now that we know we can write to a file, we need to know how to read from a file. And this is a little bit easier. And we're going to say string, and we're going to say read file. All right, so we're going to just do our try catch block. Now, for some of you, while I'm typing this out, may be reading the comments out on YouTube. There's a lot of folks saying, hey, we don't like these tutorials. We want more Qt or QML, or why are you using Dart and not Qt and QML? It's because I've done a lot of other tutorials in another language called C++ that uses a library, or I should say a bunch of libraries called the Qt. I don't want to call it the Qt framework because it's a Qt library, but it's called Qt. And it is, kind of lost my train of thought here. It runs on any platform. It's an amazing system. I still love Qt, I still love QML, and I want to do more videos on that, but right now Dart and Flutter really have my attention, so that's just kind of my focus. And we're going to say read as string sync. Now, what we're doing here is we're just saying create a new file with the file name, which creates the file object. Now that we have the file object, F in this case, we're saying F read as string sync, meaning that's going to read the contents of that entire file into one giant string and then return a variable. We're then going to take that variable and return it from this method. And what we're doing here is the default encoding, which is UTF-8, which is an entirely different conversation. Encoding is how the actual information is written and read to and from the disk. In this case, we're going to leave it as UTF-8. You can feel free to experiment and change your encoding, but just understand that not all encodings are compatible. So we're just going to leave that as default. All right, so now we have the ability to write and the ability to read. Let's test this out. Let's actually just go here, and we want to say we need to make another variable here. Let's call this txt file, and we're going to just say, just give it a very simple name, and we're going to say if write file, and we need to give it our text file, and we need to say some sort of data that we're going to write to, and we're going to say and then the mode, we're going to say append, and we're just going to play around with this for a little bit. Oops. So really what we're saying, if this, then that. So what's going on under the hood, assuming this works because we haven't actually tested the code, we're going to write to our text file, which is going to be on this path in my virtual machine, and we're going to write this data. This right here is called an escape character, and this right here is called an escape sequence. Wow, I misspelled world. That's embarrassing. So what escape does is it escapes out of the character sequence and says, I want to put a special character in here. /n stands for new return. You can, if you're on a Windows machine, I think it's /n/r or /r/n, something like that. Actually, it's the other way around. I can already tell by looking at it. It's rn, which does a hard return, a new line. That's how Windows does it, but on Linux and Mac, it's just a new line. You can also put like a tab in there. You can put special characters. You can put just anything you want. We're just doing this to break it up so there'll be a line. We're doing that because we're in append mode, and we want a new line every time we run this. Then we're going to print, and we're just reading the contents of the text file back that we just wrote, and we should see hello world down here when we run this. And you see, bang, hello world. So if we go out to our file system, you see that now there is a txt.text, or test.txt, and if we were to open this up, you can see there is hello world in there. Now let's just move this off to the side, run this again, and you see there's 2, now there's 3, now there's 4. And you can see our text file saying, hey, it's changed, we're going to reload it. And that's append mode. It's just going to keep going and going and going. Now we're going to switch this to write mode. Notice how we only have one hello world. And if we go back to our text file, reload it, there's only one. That's the difference between write and append. Append's just going to keep adding to it, where write's going to completely blow it away and start from scratch. I'm going to switch this back to append because I want to put that up on GitHub the way it is. Now, let's say we want to be able to, let me think about this for just a moment here. Let's say we want to be able to actually pump this out as JSON. So let's do that. Wasn't going to do it, but I'm like, yeah, why not? People are going to ask how to do it. So we're going to say, before we do that, I'm actually going to do something else. List. Sorry for being so scatterbrained. I'm kind of deviating from my original plan here. I'm trying to think in advance of what people are going to ask for. And what they always ask for is, okay, it's great that you can do it in one giant blob, but how do you do it in a bunch of lines? You know, how do you read lines from a file? So I'm just trying to limit the number of questions that I'm going to get off of this thing. And what we can do here is we can just say very simply, and then we can just say read line sync. And you can see how that is currently going to return a list of strings. And it's that easy right there. We could just read the lines. So let's actually do that. And let's comment this out. Actually, let's not. Let's say, see, whenever I deviate from the plan here, things happen very badly, but that's when we probably learn the most. So let's try this txt file. So we want to get the length of this. Let's run that. And you can see how there's 2, there's 3, there's 4, there's 5, there's 6. So there's 6 lines in that list object. So that is how you would read the individual lines. And I'm actually going to comment this. That was embarrassing. Wow, I really just misspelled all of that. So what read lines does is it goes in and it looks for that escape sequence of /n or /r or both, and it actually breaks those up into individual strings. So it's taking that giant string and breaking it down into 6 individual strings. All right, now we're going to go ahead and we're going to read and write some JSON here. So let's actually, all right, let's say bool to, let's say JSON2 file. I'm having a hard time figuring out what I want to call this. There we go. And then we'll say string file. Now, what we're going to do here is a little bit different. What we're going to say is map, and then we want a string and an int. We're just going to basically plagiarize what we did on our last tutorial here. Man, I am getting hungry. Like just sitting here, suddenly my stomach just starts growling. So we're going to put if absence, and we're going to say Brian. But yeah, I've had a couple of people say, what is QML? Why are people getting upset that you're not working on it? That's why I've done like, I don't even remember how many, I think like 150, 170 some odd videos. A lot. I've done a lot of those videos, and I've gotten pretty advanced in that realm. So anytime I make something that's not Qt or QML, everybody kind of wonders what the heck's going on. Yeah, I'm going to get back to it eventually. I'm actually hoping to get back to it this winter. All right, so we're going to say string JSON dot, string data equal JSON dot encode, and we're going to encode this map, and then we are going to return our write file, and we're going to say the file name, our data, and then our mode. We want this to be file mode dot write. Reason being, if we have append, we'll have multiple JSON objects in there, and it'll probably crash the program, or it will just get garbage back, or we won't get the latest object. Something bad will happen. All right, so we've got JSON2 file. Actually, let's call this write JSON. There, that's better. Now I'm happy with it. Now we're going to say void. We're going to read the JSON. I fought JSON for a long time. I was really into XML. I did not like JSON when it first came out. XML has just been around forever, but it's horribly inefficient. All right, string data equal, and we want to actually read the file. So we're just reusing the code that we wrote. So rather than reinvent the wheel with the write file and read file, we're just reusing our functions here. Now we need to do a little bit of error handling here. You notice how write.json is just returning the value of write file. Now with this, we can't do that. So what we need to do is say if data.isEmpty, then we're going to say print no data, and then we're just going to return out of this function. And we should also get the error string from the actual right here, from the actual method. All right, now that we know that we have data, because at this point we should have data, I'm going to say map string int. This is the structure of our map here. Structure of our map. That really didn't make a whole lot of sense, but I think you guys knew what I meant. All right, so we're going to say people equal JSON.decode, and we're just going to decode that data into an actual object. And then from there, we're going to say print we want to know what the people object contains, just so that we can prove that we actually decoded this. We're going to say people.forEach, and then we're going to say key, comma, value. Let me scroll this down a little bit so you guys can see what's going on. And then we're just going to print these out. All right, so that should work. Let's actually put this down in our main function here. And we need a new file name. So we're going to put this into a different file here. And then we are going to simply say if write.json, txt.json, then what we want to do is there we go. So when we run this, assuming it's all going to work, we'll get another, we'll get another file out here. Let me actually go to our directory here. We'll get another file out here called json.txt, and it will contain our JSON object. And then if it returns true in the write, where is it? Right here. If that returns true, then write.json will return true. Then we'll actually read it back, and then we will go through this object and print it out after we've decoded it from string. So this may seem a little complex, but this is actually a really good real-world example. This is really what JSON's designed for, is you would take an object, encode it down to a string, pump it across the network or internet or whatever, and then your consumer, as it's called, the consumer application would take it, read that string, decode it back into an object, and then work with it. And woof, that scared me. It actually did work the first time. You can see we have 7 hello worlds, and our people object contains Brian is 43 years old and Heather's 25 years old. And sure enough, there's our JSON file, and there is our JSON object that got written down to disk. Whew, that was a mouthful, and I'm glad we didn't have any major errors because I'm tired and I'm hungry. So I'm going to go get some food, but before I do that, I wanted to thank you guys for watching, and you can find the source code for this and all other tutorials out on my website, voidrealms.com. Just click on GitHub, and then go out to all the tutorials. I got the Flutter tutorials here, and then all the source code. On top of that, feel free to visit the Void Realms Facebook group. We have 1,700 plus and counting programmers, all different languages. I warn you right now, most of those animals love C++, so you may get a little flack if you post a Flutter question, but actually everybody's pretty decent in there, so they'll probably help you. And that's it. Thanks for watching. Everybody, this is Brian. Welcome to our 18th Flutter tutorial. We're going to hopefully today wrap up our Dart conversation and then move into Flutter in the next tutorial. The reason why I want to do this one is it kind of goes through a overview of libraries and how to use them, which we've talked about a little bit, but not really in depth. So if you kind of just poke around Dart, you'll find that there is a pub.dartlang.org, and you get to it by going to libraries. And then you can actually view the tour of libraries, how to create packages, how to commonly use libraries, which I highly recommend you look at. But you'll see that pub is a tool for managing Dart packages, and we've talked about that before. And we've even talked about pub.dartlang. When we go out there, you can search for just about anything. I mean, if you've thought about it, it's already out there, which is just nuts because Flutter itself is in alpha. Dart's been out for a while, but just about anything you can think of. And back to the commonly used, you can see they've got a wrapper for Firebase, HTTP, internationalization, I can never say that right, logging. I mean, we've been over some of these before. So what I want to do today is really go over how to really integrate those into your project. We haven't really covered that. So if you're out there, you can search for HTTP or image, and I've got both pages up. Really, we're just going to work with these two. What we're going to do is we're going to download an image and actually resize it. And we're just going to show just how dead simple this is. And in other languages, this is a total nightmare of a project. Your boss says, well, we want to download this image and resize it. And you're thinking, I got to go find a image library. I got to figure out how to work with HTTP. I've got to, do the get and the put and all that. No, it's dead simple. So let's just jump right into this. And we're going to make a console application in Dart. And we're going to call this downloader. All right, and this will load our project and load all the dependencies and calculate the meaning of life. Sometimes I really wonder under the hood with that thing. All right, so one thing we really haven't talked about is when you open a project, it opens these three files for you automatically. It opens this file, which is your code file out in your lib, this little guy. It opens the main file, which we've worked with many, many times, which is that guy, and then this pubspec.yaml. Notice how in YAML there is a dev dependencies. That's what we're really going to be working with here. So let's just kill that. And we're going to get this and get that out of there. Now, let's flip back. To use anything that we find out in the Dart packages, like we just search for HTTP. You can see that's how I got to it right there. Once you get to the page, you can do the README file. You can see who the author is. The HTTP package was actually done by the Dart team itself, and it's got some example code on how to use it. Now, not all of these are created equal, meaning you will find packages that have just absolutely zero documentation. So in that case, you would reach out to the author and say, hey, how do I use this thing? This is pretty straightforward, and it works with streams. So under the hood, there's a lot going on, but to use it, it's dead simple. What you always want to look at is how to install it. Depend on it. So you open the dependencies, you open the YAML file, copy this little bit here, and then put it in the dependencies. So we're going to do that. And we're going to do the same thing with image. We're going to go to installing, going to grab this, and we're just going to put that in there. So save that YAML file. There are really two ways of doing this, but the easy way is just flip over to main.dart and you can see how, hey, pubspec has been edited. This file right here that we just did. What do you want to do? Do you want to upgrade, get, ignore? Well, we want to get because we don't actually have those yet. You can see there's our pub file, or pub folder right here. The little dot denotes that it's a hidden folder. So we're going to get dependencies. And that may take a second depending on your download speeds. All right, once we're done, you should see that the little indicator has gone away. And if we run through here, I think we may actually see them. Yep, there's HTTP right there. I'm not seeing image. I'm wondering where that went. Maybe I'm wrong, but I'm pretty sure that's where it is. That's 11.316. There it is. Oh, there it is right here. Image. Derp. Now I feel very stupid. So that's where they end up going, is under external libraries. And they get bundled with your Dart package here. So we're going to kill that. Go in here. Now we want to actually use these things, right? So many times it's very simple, very easily documented. It's right under here. They tell you how to do a pub get. You can do a Flutter packages get. This is all command line work that we didn't have to do. And then you can import it right here just by copying and pasting. So we're going to copy that for the image. Go back out here. And we're going to copy that for our HTTP. Now, if you have no idea what HTTP is, it's Hypertext Transfer Protocol. It's basically how you communicate on the web. When you open a browser and you go to a web page, it's actually talking a language called HTTP. It's a protocol. So we also want Dart.io. We need to set a few things up here. So what we're going to do is we're going to say void download the premise here being that we are going to download something and we are going to resize it. So what we need to do is actually set up our variables. String URL, and because I just am dead lazy and I do not want to type that whole thing out, bam, we're just going to do this. If you're wondering what it is, it's just the hot reload GIF. This guy. So we're going to download this and resize it. And then we're going to say all right, so now I need a file name. Let's just grab this. See where I'm at on my virtual machine here. I probably should have known where that was, but so we got the directory, and we're just going to say test.gif, and then we're going to say preview.gif. So we've got our variable set up. Now we're just going to simply call the function. Yeah, see, if we would have named that to path instead of file, it would have just done it for us automatically. All right, so a lot of typing so far. Not really. Let's actually make the magic happen, as they say. So we're going to say oh, yeah, I missed a step. That's why that's not working. We want to do this as HTTP. So if you're wondering what I'm doing here, is we want to use the image package, but we don't want to import it as a variable. We just want to actually use it. Whereas the HTTP package, we want to actually import this and create a variable. I'm just kind of showing two different ways of doing this here. That way we can just call HTTP dot, and bang, we've got an instance of that variable already. We're going to say read bytes. And you notice how we've got some parameters here, and it looks really nasty and ugly, but really you don't have to mess with that too much. We're just going to say the URL, which is our variable. So it's going to take that URL, go out there, and it's going to do the HTTP protocol in the background. It's going to read it as bytes, and it's going to return a variable we're calling data. And when that blah, then we need to do a then on the data itself. What's really going on here is, well, you guessed it. We're working with an asynchronous function. Whoops, that didn't work as planned. There we go, kind of. That's a little better. Those always trip me up. I'm still not used to those for whatever reason. They just mess me all up. So what we've got so far is we're going out, we're reading the URL as a byte stream, and then once it's done, we've got the data itself. I probably shouldn't call that data. Let's call this, what should we call this? F data. Why not? That way it's not super confusing what we're doing here. Then we're going to say file, F equal new file from the path. So then once we actually have the file, we're going to, or once we have the data, we're going to open a file. And we are going to actually dump that data down to the disk. And we're going to say random access file. And we've done this before as far as opening the file. And what we want to do here is we want to open sync because we don't want to mess around with any of the asynchronous stuff just because I'm being a little lazy this morning. And we want to just write to that file. And here we want to do what's called write from sync. And you notice how it's taking a templated list using ints. Now really what that is our actual byte stream. So we're going to do that. And we're going to say fdata. Actually, we could just call that buffer. It'd probably be easier. Why didn't I think of that? Genius. Man, these Dart developers are just awesome. All right, so then we're going to flush sync, and then we're going to close sync. That way we've got our synchronous code in there. We don't have to worry about any weird timing issues that are going to pop up due to asynchronous calls. Then we want to actually resize the image. So let's put some commenting in here. All right, so now that we've actually got the file down to the disk, what we want to do is we want to actually resize it. And here we're going to use the image library. So there's image, I shouldn't call it image library, image package. I think the two terms are kind of interchangeable. And we want to actually decode image. And we could actually take that buffer. You see how it is a list int, but what I want to do is I want to actually grab the file. So we're going to say new file. And we want read as byte sync. So really we're just going to say, hey, image, decode the image, meaning it's going to read in the raw bytes. And then it's going to decode that because every image has a certain codec. It's not really a codec, it's called an encoding. You know, the difference between a bitmap or a GIF or a JPEG or something like that is the encoding that it actually uses. So it's going to decode that image by using the bytes that we're reading from the actual file on the disk. Whew. Sound confusing? Now you know why this tutorial gets a little nuts in other languages. All right, so now that we've actually got the image in memory, we want to actually resize it. Actually, I should say load the image. Now we're going to resize the image. All right, so we're going to say image thumbnail, and we want to copy resize, and we're going to take the actual image. And we want this to be 200 pixels. Then once we're done, we want to save the thumbnail out to the disk. So we're going to say and we want to do write bytes as sync. And we want to actually do this as a PNG, not a GIF, because why not? But you can see how you can encode it as a GIF, GIF animation, JPEG, TGA. You can do a named image type, things like that. So there's a lot of power in this little package here. So we're going to encode this as a PNG. All right, so that is a lot of typing. Let's see if this actually works. You notice how right now we've got absolutely nothing out in our folder except for a few other folders and the video that I'm currently recording. We're going to download that file and encode it. You can see process finished, exit code 0. And you can see how there is our test. Yeah, that is not a GIF file, that's why. Let's rename that to a PNG. Okay, it's just simply because I had the name wrong. There is our encoded here. To kind of solidify that this actually does work, we're going to delete all this nonsense. And we're going to actually fix this, because remember in the very end I changed it to a PNG instead of a GIF. So what we're doing is we're downloading the GIF, putting it on the disk, and then we're changing the size and changing the encoding. Sorry, I kind of confused you a little bit, but I wanted to do both just to show that it could. And then it's just going to work. Nothing up my sleeve, ladies and gentlemen. And bam, you can see it's actually writing it out to disk. And when it's done, which it is, you can see here is the full-sized. That's not working for some reason. It is there, trust me. And there is our thumbnail. I wonder why this one isn't working. I'll have to figure that out. Oh, there it goes. I was just impatient. It was still loading. So you notice how this is animated, whereas the actual preview is not animated. That is in part due to the encoding, which is right here, encode PNG. So let's see if we can go encode, and I'm not sure how that works, but you could do encode GIF animation, and then you would have to do the animation part. I'm not sure how to do that, to be brutally honest. It's kind of out of the scope of this tutorial, but just wanted you to be aware that that could happen. So that is a pretty complex little application in a very small package. I'm really impressed by how Dart packages work and how everything just kind of fits together. And I wanted to kind of do this tutorial before we, just head first into Flutter to show that you can get this level of complexity in a very small, simple to easy to use package. So if it seemed a little bit confusing, it's because it's kind of a confusing topic. And there's a lot of information that we're skipping over. Like we haven't really touched on encoding and decoding. We haven't touched on HTTP get and put and delete and all that stuff. We also really didn't talk a whole lot about the real under the hood differences between these image formats. But you can see now how to actually download a file off the internet and then work with it using the image package. A lot of talking. I think I'm spent. That's all for this tutorial. I hope you found this educational and entertaining, and thank you for watching. Oh, and be sure to visit my website, voidrealms.com, for the source code for this and other tutorials. Hey everybody, this is Brian, and welcome to the 19th Flutter tutorial. Today we're going to actually start working with Flutter. I'm so excited. All right, so just for reference, you need to know Dart, which is a programming language. You can find that at dartlang.org in case you skipped the other tutorials. Flutter's main page is flutter.io. Now there is a lot of information here. I mean tons. This is very heavily documented, even for being an alpha. I was very surprised. We did actually already install Flutter, but if you haven't already, if you haven't been following along, go ahead and install it for your OS. It's just dead simple on how to do it. Really, you just go to your operating system, follow the directions, and boom. Now, before we do any of that, what we should do is do what's called Flutter Update and Flutter Doctor. Maybe it's not update, maybe it's upgrade. There we go. So do Flutter upgrade, and then it will actually make sure that everything's up to date and everything's the way it should be. And I think it actually runs Flutter Doctor for us, but we're going to run it separately just so I can show you what it does. We've been working with this for a while, and because it's in alpha, it's going to change very rapidly. So we want to make sure that we have everything up to date before we really start diving into this. All right, now some prerequisites here, and I'm going to actually run Flutter Doctor just so you can see the prerequisites. Wow, can't not spell doctor. When you run Flutter Doctor, it will make this nice list for you showing you, hey, if you try to work with Flutter, this is where you are. And you see how mine is nice and beautiful. It's got little check boxes next to everything. It's saying we have Flutter on, and then I have it on my virtual machine. And we have the Android tool chain. What this means is I already have the Android SDK, I have Android Studio, I have the Android NDK, and all that stuff actually on there and configured. I know it says on my screen I do not have an NDK, but I actually do. I just haven't pointed it anywhere. And then I have Android Studio installed. I have IntelliJ Community Edition. I have no connected devices, but that is easily solvable. Once you install the Android toolchain, especially Android Studio, you get what are called virtual phones or virtual devices. We will be working with virtual devices in this tutorial. So before you go ahead with any of this, whether you are on Mac, Linux, or Windows, I would highly recommend that you stop what you're doing, actually pause this video, and go out and download either Android Studio or iOS with Xcode. I'm going to be working with Android Studio. I may later work with iOS. Video recording works a lot better on my Linux virtual machine than it does on my Mac for some reason. Everything that you do in Flutter should work on both iOS and Android. So have no fear which one you're working on. They may look a little different, but under the hood, they should work. Now, once you have those installed and configured, come back to this point in the video. I'm not going to cover how to do that because it's going to vary drastically on your operating system and your configuration, and there are literally thousands of videos out there. So go to Google, go to YouTube, look on how to install Android Studio, actually go out and do it. All right, once you've got that, come back, run Flutter Doctor again, and once you have all these check marks saying, hey, you're good, you could probably go ahead and work with it. Now, on my Mac, I can work with it, but it's saying that I'm missing some dependency on Xcode, which is just blasphemous because I work with Xcode almost every day on personal projects. So, without further ado, let's actually create a new project. Now, this time, instead of Dart, we're going to click on Flutter. You notice how we have a lot less options, and if you don't have the SDK pointed, it's going to say install SDK. It makes it very nice and simple for you. Now, this is where things get really super interesting with Flutter. Notice how we have this nice, beautiful list of options, and I was blown away when I first saw this. We're going to say first Flutter, not fist Flutter. Jeez. Fisting Flutter. Boy, I'm sure somebody out there is laughing pretty hard about that. One of the devs is like, hey, Brian's going to fist Flutter. Anyways, so we've got our name, we've got our location, we can give it a description. You can give it a type. We want to do an application. Organization, your company. This is pretty standard naming convention. It's backwards from your DNS name of whatever website you have. So in my case, it would be Void Realms. Let's actually do that. I am not good on the typing today. All right, then notice how there's an Android and an iOS language. And that's because it builds an application for Android and iOS. And you can choose which language, because you can do it in Java or Colton. You can do it in Objective-C or Swift. I'm just going to leave those as the defaults. And then I'm going to hit finish. And this may take just a second as it builds our project in the background for us. All right, so first thing we get is this big, beautiful project, a lot of code. And it's pretty well documented. You can see there's huge chunks of documentation in there. Whoops. And it's got all of the packages that we need already in there. It's got the Dart SDK, it's got Flutter for Android. And you notice how that says flutter.jar because we are working with Java for Android, even though we are actually working with Dart and Flutter. The project structure is a little bit different than what we're used to. You notice how we have an idea folder, we have an Android folder, which is actually our Android project, and we have all our Gradle settings and all that you would expect from an Android project. We also have an iOS folder. We have a test folder, and then we have all the things that you would expect, including our pubspec.yaml. Now, one thing to note is this has the uses material design, and we'll get into material design in future tutorials, but just understand that that is a necessity for this to work, and it should be under the Flutter section. Now, there is one folder called lib, and in there is main.dart, which is this beautiful file that we're looking at now. Let's actually minimize that so we can see this code. We're going to just go through this code. There's no sense in retyping all this. It did it for us. And you can see how we have our main, and that is just calling run app, and we're making a new my app. My app is a class that extends what's called a stateless widget. There's stateful and stateless widgets. Stateless widgets have no concept of what a state is. Stateful widgets hold a state. So what is a state? A state is, well, think of it as a variable. I don't know why they didn't call it like variable widget or something, but state is kind of like the de facto language in the mobile world. You have to have a certain state. So if you are, let's say, on your phone and you type something, that is part of the state, because if you minimize that application, some operating systems will actually either suspend it in memory or just flat out delete it in memory. And then when you bring it back up, you have to restore that state. You have to put it back the way it was. So think of a state kind of like if you're married and like your wife's attitude. You say, hey, you want to go get tacos? And she's like, no, I hate tacos. Well, now she's mad at you because you want tacos. That's her state. But then you say, hey, let's go get a pizza. And then suddenly she's happy. So that's what state is. So we have two different things. We have stateless and stateful. Whoops. Stateful. So we're running an instance of my app. This is where things get a little weird. We have a stateless widget. That is called our root widget, meaning everything else is a child of this, of some type. You can see how in there it has a build method, which is returning a widget. Everything is a widget. Widget is just, if you're not from the United States, widget is just a generic term meaning it's a thing. Every widget will return a build function, or will have a build function which returns a widget. What the build function does is it marks things in memory based on their state, meaning what has changed. And you can see we've got some properties here. We're going to return a new material app. Now, we mentioned material before in our pubspec YAML. Uses material design. Now we have a material app. We're going to get into a little more in depth in this, but really just think of this as like a blank piece of paper in front of you. And on that piece of paper, you're going to draw out all your little widgets and everything that you need for this to function properly. And on that paper, the first thing we're doing is saying the primary color is blue. And you can see in the directions it says, basically change it from like blue to green. We'll do that here in a minute. And then the home property is a new My Home page with a title. My Home page extends a stateful widget, meaning it knows there's a state, it knows something's going to change. And then we have our little constructors here. And then there is our actual state right here, this string. Notice how it's saying create state underscore my home page state, which means it's a private class, because that is how Dart denotes scope between public and private, is that little underscore. And it extends my home page. Well, my home page is here. So we have my home page creating underscore my home page state. My home page state is extending my home page. So you have a bit of a circular reference here, and this gets very, very confusing very early on, because you're like, I don't understand why my home page just can't have everything that I need. Why are we doing this twice? There was a very long article, and I wish I had remembered it, but basically it said that the stateful widget is just a container, if you will, and container is actually not the right word. They used a different term, but it basically holds the state, where the state itself is what's going to change. See how this is underscore my homepage extends state, meaning we know it's going to change. And the type of state it's going to change is the my homepage. Bam, this guy. So that's what we got. Now, and when I say that's what we got, that's just a property of the my homepage. The actual state is this underscore my homepage. If that sounds confusing, it's because it is very, very, very confusing. So Flutter developers, if you are watching this, please make that simpler. Make it more easy to understand, because I spent about an evening with a cup of hot chocolate just cursing at my laptop screen trying to figure out what you were doing. But once you think of it as, you're going to create state, at the state you're going to create is just simply this My Home Page, and just drink the Kool-Aid, accept it as is, then it makes a little bit of sense. So the My Home Page state, because that's what that is just simply going to increment a counter, and then there's the counter we're going to increment. Notice how in this increment counter there is a set state function. I should say set state method. And it literally says this call to set state tells Flutter Framework that something has changed in the state, which will rerun the build method. Remember, every widget has a build method. So in here, we're going to build based on that set state changing the counter. And then in there, don't worry if all of this sounds like ancient Egyptian algebra, we're going to cover this in depth in future tutorials. I'm just giving you a high level overview. But in there you have what's called a scaffold. So the build method of the My Home Page state is just returning a scaffold. Think of a scaffold as, well, it's pretty self-explanatory, a scaffold outside of a building. It helps you put things in a certain structure. In that scaffold, we have an app bar, we have a body, and that body has children. If that sounds like a lot to digest, don't worry, it is. It's just the basic structure of a Flutter application. Now we want to run this to conclude this application. So you see how it says no devices? We have the Android Studio installed, and we have an emulator in there. So first thing it's going to do is open up our emulator for us. And we're just going to wait for this to run. Well, that's a little slow, so while that's loading, I'm going to actually just add in some notes here. Alright, so we've got our little Android device up and running. And what we want to do next is actually run this and put it on the device. So we're going to just click this little run guy. So you can see how we're running it on this device, and this is what we're running. And we're just going to, bam, run that, and you'll see it'll actually go out. And it'll start building it. It's initializing Gradle because Gradle's part of the Android toolchain. I shouldn't say it's a part of the Android toolchain. It's used by the Android toolchain. And then it's going to take just a minute to really build this thing and throw it out there. Once it does, you have something called hot reloading, meaning you don't have to do this every single time. You can just leave the emulator up and running, and as you make changes in your code, in the background, it's going to push those changes out to the device. All right, so real quickly, here is our app bar if you're looking at the code. Here's our home. Let's actually highlight it here. Down in our scaffold, app bar is this blue thing. The body is a new center. Notice how that's a new center, not just center. So center itself is a widget, so we're centering things. And in there we have children. We have a text that says you have pushed the button this many times, which is the new text counter. And it just works. There's the state. You can see the state changing in the background. Now, notice how this is blue. We're going to go in here, and we're going to say color green. It's still blue. Let me go in here and save it. And as soon as I save it, notice how it actually changes it. We didn't have to repush anything out. We didn't have to rebuild anything. It did what's called a hot reload. So that's it for this tutorial. I know it's been very informative, and a lot of this is probably still very fuzzy in your mind, and that's to be expected. We're going to start diving into this thing in the future tutorials. Thank you for watching. I hope you found this educational and entertaining. And all the source code for this and the tutorials are out in the tutorial section of my website, voidrealms.com. They're actually out on GitHub, but this just links right to the actual tutorials. On top of that, Hey everybody, this is Brian, and welcome to the, what are we on, what the heck? We're on the 20th tutorial, but I literally just published 18, 19 not too long ago, and there's already like 50 views on each. I have a feeling there's a small group of you out there like watching these as soon as they come out. Anyways, so what we're going to do today is we're going to do the obligatory Hello World application. If you don't know what I mean by obligatory, every time you start a new language or framework, it's kind of like the traditional thing to do to make a Hello World application. It literally just displays Hello World on the screen. We're going to take it a step further because I think those are pretty elementary. And we're going to see what it takes to build a basic application. I mean, we're talking real bare bones here. If in case you're wondering where we're at, we've installed Flutter, we've created our first app, we've set up an IDE, and we've learned Dart. So we're in the tour of the framework, and we're actually on this second bullet point, Hello World. So we've taken this code, Hello World right here, and we put this into a new Flutter application. And we've got our emulator up, ta-da, and we're just going to run this thing. Now I have kind of a bone to pick with the Flutter developers because this is a little misleading, and I'm going to explain in depth in this detail in this tutorial why it's misleading. You can see how it's Hello World, so it literally just displays something. Bang, our job is done. Not quite. Let's say we wanted to put a button here. Well, you can see, let's just pick this apart. The import package flutter material.dart. We're going to talk about material a lot. Main, we have our run app, which is kind of the starting point of any Flutter application. And in there, we're going to say it's going to return a new center, which is just going to center everything. The child of that is a new text. In that text is Hello World with a text direction of left to right. Now, for that to work, uses material design true must be in the Flutter section of the pubspec YAML. Remember, burn it into your mind. We are going to talk about material a lot. So, looking at this, I thought, well, it'd be cool if we could just see what's out there. So I clicked on Widget Catalog, went to the basics, and said, oh, these are kind of neat. Hey, they have a button. Buttons are always fun. So let's just view the documentation on this and say, yeah, let's just throw a button out here and see what it takes to get a button on here. So it seems like it's pretty simple. We could just take this, new raise button. Notice how it's nice enough to put the on pressed equal null for us, so we can actually link that to a method. And initializing hot reload, and notice how nothing happened. So we're going to kill this. Typically when hot reload doesn't work, it means there was a problem. And it says some elements were changed during reload but did not run when viewed as assembled. You may need to restart the app for the changes to take effect. So let's run this. Let it rebuild. And I have to apologize if my voice cracks a little bit. I feel like I'm coming down with a cold or something. It's like first snow of the year. It's pouring snow outside. I live in Michigan, so I'm sure I'm coming down with something. So as you can see, mistakes were made. All right, so this is the same error message over and over again, separated by this line. So we're just going to start reading here so you can actually see it. It says no material widget found. Material button widgets require a material widget ancestor. In material design, most widgets are conceptually quote-unquote printed on a sheet of material. In Flutter's material library, that material is represented by the material widget. It is the material widget that renders ink splashes, for instance. Because of this, many material library widgets require there be a material blah, 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 blah. Really what that's saying is your root widget here needs to be a material widget. It needs to inherit material design. Now, what do I mean by material design? This is where you kind of have to take a little bit of a leap of faith because it doesn't really transition smoothly into this. You can see how there's basic widgets and then using material design. So I kind of think material design should be up above. But there is a whole material design guideline here. And you can see how there's a material app. Really what it means is conceptually, think of your application as a desk, and on that desk you're going to put a piece of paper, and on that piece of paper you'll start drawing your widgets and scaffolds and app bars and all those neat little things. So click on Material App and you can see how overall satisfied with Flutter. Well, I'm going to put somewhat because we've had a boo-boo. No, sorry Google, I'm not going to fill that out. All right, so maybe if I wasn't doing a tutorial when you popped up, I'd fill that out. But you can see Material App is an application that uses material design. All right, so we're headed in the right direction here. And it's a convenience widget that wraps a number of the widgets that are commonly required for material design applications. It builds upon widget app as adding material-design specific functionality such as animated theme and grid paper. All right, and you can see it also says scaffold, navigator, and things like that. So it sounds like a lot of what we need. So what we're going to do here is we're going to get rid of this. And we're going to say new material app. Actually, let's not do that. Let's break this out. We're going to extend the stateless widget. We're not going to worry about state in this application. And what we're doing here is kind of just the bread and butter of almost all Flutter applications here. Let's say new my app. And of course, hot reload won't work because we have a boo-boo here because we're not returning something. So in here, what we're going to do is we're going to return a new material app. All right, so notice how the little red squigglies went away. So the code thinks it's correct. We still got that error message up, so we're going to kill the app, and we're going to rebuild it and send it out to the device and see what happens here. All right, so pushed it out. Uh-oh, we have a boo-boo. It says, and remember the same error message over and over again, it's just in these lines. Package, blah, 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 Flutter, source material app, Dart, failed assertion, line home equal null. Home equal null, or home not equal null. Basically, it's saying the home is null. So we need to give some sort of home. We need to figure out what's going on here, right? It's part of material design here, and it's not really well spelled out. At least I didn't find it right away following the Flutter docs. So there's home. It's actually part of the material app. And basically it was an assert call that said, hey, this is null, so we need to figure out what to put here. So let's make a new scaffold. And let's just save this. Notice how it says initializing hot reload and then reloaded, meaning we go back here and ta-da, it suddenly put something out on the screen. We have a big white box. So what is this thing? And notice how it says slow mode. You may not be able to see it over that clock, but it says slow mode. Okay, so my app is a stateless widget, which is just, a widget. And then the build is going to return or render. Whenever you see return and build, basically we're rendering a material app. So this giant white box is the material app. The slow mode basically means that we have not compiled this for production yet. This is like a debug version, if you will. So it's not really meant for the real world. We're just doing this because we're goofing around on our computer. If we were to send this to like the Apple Store or the Google Play Store, we would want to compile this for production and actually make it so that it's not in slow mode, which we may cover in future tutorials. Actually, we'll probably cover in future tutorials. So you will see slow mode a lot. Don't be alarmed. So this is a pretty plain application. What does the scaffold really do for us? Why are we messing with that? Think of a scaffold, well, like a scaffold. You see these around buildings when people are washing windows or painting. They're just, structures that you put up so that you can get to different parts of the application or different parts of the building in that analogy. So what we're going to do here is app bar equal new app bar. Let's actually say Flutter. Hello, Flutter. And you can see hot reload worked. So suddenly we have a app bar. So the app bar is this top blue section. And really all this does is it lets the user know what you're working with, the name of the application or what page in the application, and you can put buttons and things of that nature up here. Think of it like a giant toolbar. Now, this extra white area down here is called the body, and that's what we're going to work with next. Body would be the body or the working area that the end user would actually work with here. So we're going to say new, center, and then in center we're going to say child, new text, save that, hot reload will pick it up, and then bang, centered is our hello world. So remember, the whole goal of this is we just wanted to put a button on the screen. So let's figure that out. Let's get rid of this. So we're going to put our new raise button and save this. And notice how it hot reloaded that time. So this little gray thing is actually our button. We want to put some text in there so we can kind of see what's going on here. Let's actually my button. And we'll break this out into a new line so it's easier to read what's going on here. Whoops. There we go. So very faintly, grayed out, it says my button. It's grayed out because we don't have an on press in here. So we have our app bar, we have our body, and in our body is centered, we have our button. So why didn't this work before and why is it working now? That's the million-dollar question. Remember at the very beginning of this, when we tried adding the button, it said it needed an ancestor of material widget. It needed material design. You're going to hear material over and over and over again. While you don't have to use material widgets in material design, you would be fighting a massive uphill battle. Kind of the de facto way of doing things in Flutter is to use material design. That's why I wanted to start this with the material app, because it's the bread and butter of what you're going to be working with in the future. So that's why it's working now, because as you can see, the button is actually part of this widget tree, and the root of that tree is a material app that has all the material goodness that we need. Whew. So that is a lot of talking. I hope you found this educational and entertaining, and we're going to work with this a bit more. I think the next video we're going to actually do some basic layouts and just kind of figure out how things are laid out. But I wanted to show you just the bare bones Flutter application, like a real quote-unquote application, not the little hello world they had out on their website. If you found this educational and entertaining,